So the first thing I wrote at the top, and I want you to do the same, is to take out the GCF. Always, always, always look to do this first. Because otherwise, a lot of things are not going to look factorable. Okay? So on this first example, we have a GCF of 2x. We would take that out. We're left with x squared plus 4x plus 4. Now, once you take out the GCF, you can focus on a stripped down, easier version of the polynomial to factor. Now, this is a trinomial, so we can either guess and check if you think that you're better at that, or we can split the middle term. Kaylee Smith, take your pick. Would you prefer to split the middle term or guess and check? What's your favorite? Guess and check. These are fairly small numbers, so guessing and checking on this is not so bad. The first two have to multiply to get x squared. So Connor, what does that have to be? X and x. My last term is a positive. What does that tell me, Maggie? Same sign, and what sign are we going to use because of the middle? Very good. So same sign, and they both have to be positive. And then we have to find two numbers that multiply to get 4. It's either 2 and 2 or 4 and 1, so that the outer and the inner make 4x. Mason, what is it? 2 and 2. We just double check. Outer is 2x, inner is 2x, and yes, that combines to be 4x. Now, the GCF that we took out has to be written in front. And there's your final answer. Okay? So I started with a trinomial. How many factors did that factor into, would you say? How many? I see why you're saying 3. I would actually say that there's 4. It's 2, that's one factor, times x, that's a second factor, times x plus 2, that's a third factor, times another x plus 2, that's a fourth factor. Actually, the more efficient way to write this, now that I'm realizing that, if it was multiple choice, it would probably be written this way, because we have the x plus 2 coming up twice. This would not be wrong by any stretch, but if it was multiple choice, they'd probably have it written this way. Okie doke. Isaiah, what's the GCF on example number 2? 5x. And when I pull that out, I have that. Now, once we pull that out, look at what's left. The x squared minus 9. Grace, how do I factor x squared minus 9? Correct. X minus 3, x plus 3. Those are the conjugates. And then put your 5x out in front. So that was a difference of perfect square special pattern factoring into conjugates. Important word. Any questions on that? Okay. GCF. Aiden, what do you see as far as a GCF on this one? Correct. So all we have is a 4-term polynomial. What's our method with 4 terms? Starts with a G. Grouping. Yeah, I know what you meant, Mason, but I'm just going to keep my language consistent. So I pull out an x squared. I'm left with x plus 3. What do I pull out here? Minus 25. I'm left with an x plus 3. So my two factors are what, Bo? And? Good. Now this is where factoring completely comes in, because this is not done. You cannot leave something in your final answer that can be factored further. And Zach, which one of these can be factored further? Good. Into conjugates. X plus 5, x minus 5, and then we of course keep our x plus 3. It's a little bit tricky because you get done with grouping and you're like, deep breath, you finish, it worked out, you're good to go. But then look again, you're not, okay? So you can get wrapped up in the fact that you just completed this long process of grouping with success, and then you just move to the next. X squared plus 36. This is the sum of perfect squares. This is not factorable. If something is not factorable, what do you call it? Starts with a P. R prime, good. The sum of perfect squares. Don't try to do conjugates with that. It is not the difference of perfect squares. It is the sum of perfect squares right there. Okay, the next exercise is, what do you see here? Any GCF? 4 terms, right? So you naturally would think, oh, grouping, right? But pause. Do not go ahead. Watch what's going to happen if I try to group. What's the GCF? There is none, so technically I take out a 1, right? Don't do it. Don't do a thing, because this is wrong. But this is me predicting what you would do. What's the GCF of this one? 20. And how do I know that grouping did not work? Because these aren't the same. Okay? So grouping that 4-term polynomial 2 by 2, which is the only form of grouping you've seen so far, you cannot do. So I'm about to show you a couple other methods of grouping. Do you see x squared, 20x, and 100? Okay, I'm going to rearrange this. So x squared plus 20x plus 100 minus 36a squared. I just rearranged it. Because you don't have to group 2 by 2. You can group, now 2 by 2 grouping is the most common, but you can group 3 by 1 if you want. Because this first trinomial is factorable into what? It's a special pattern, right? This is a perfect square. This is a perfect square. 10x, and the middle term is double it, right? So this factors into x plus 10, x plus 10, aka x plus 10 squared. Minus 36a squared. Does everyone see what just happened there? Now what I'm looking at is the difference of a perfect square and a perfect square. So this is now going to factor into conjugates. Okay? Something plus something and something minus something. You get those from the square roots. What's the square root of this first term? What's the square root of x plus 10 squared? Just x plus 10. And what's the square root of this one? 6a. So it's x plus 10 plus 6a, x plus 10 minus 6a. Definitely a little bit tricky, yeah? Number 1, you have to fail at the 2 by 2 grouping. Number 2, you kind of have to get a gut instinct, and the more you see, the better you'll be at this. Get a gut instinct as to how to rearrange this so that the x squared, 20x, and 100 are next to each other. And then once you do that, you have to see the difference of perfect squares and be able to take square root plus square root and square root minus square root to get your final answer. Does that make sense? The next one is going to be similar to that. How do you think we should rearrange this? Nathan H. Perfect. And then this trinomial factors into what? Think about that for a second. Kaylee M? Well, it really factors into it like as a trinomial. So if you guess and check, it's x and x. And then what times itself would give you the 16, so that the outer and inner make 8. 4 and 4, plus 4 plus 4. But the more efficient way of writing that is x plus 4 squared. And then just like the last one, we have the difference of two perfect squares. So we have to do the square root plus the square root and the square root minus the square root. So what is that going to look like? Jake. Good? Perfect. Nice job. Those are tricky. Okay, so just look out for that on your homework. Okay, on our back side we have how many terms? 6. Is there an overall GCF? No. So here's the thing with 6 terms. We are either going to group 2 by 2 by 2 or 3 by 3. And it's sort of trial and error. Okay? So don't do this until we confirm. I don't want you to have to erase, just watch. I'm going to first try 3 by 3 and hope that it's right. What's my GCF of the first 3? K squared, so I would be left with k squared minus 4 plus 8k. What's the GCF of the next 3? Negative 4. Does 4 go into all those? 8. 8 doesn't go into 12. So 4. Negative 4 would leave 8k minus 3k squared plus 12. Do they match? Okay, so that was a bomb. I'm going to get rid of that. But 3 by 3 sometimes can work. I'm going to do a 2 by 2 by 2, and I'm going to have you do this because I know that this is going to work. What's my GCF of the first 2? K squared. Take that out. You're left with k squared minus 4. Plus, my GCF of the next 2 is 8k. I'm left with k squared minus 4. So far, so good because they match, right? On my next group, my GCF is just 12. So I'm left with k squared minus 4. Now, because there were 3 groups, all 3 have to match, and they do, right? So what's the GCF of all 3 of these that I'm taking out in front? These all have a k squared minus 4, so I'm taking that out in front. And what am I left with? Andrew? Right, a trinomial. The k squared here, the 8k here, and the 12. Now, k squared minus 4 should look like it needs more work. It does. That's k plus 2 and k minus 2. The trinomial might be debatable. Is that factorable further? You got to play around with it. Worst case scenario, see if you can split the middle term. Are there 2 numbers that multiply to get 12 and add up to get 8? 2 and 6. So if you can find those 2 numbers and they exist, then that means it is factorable further. If you want to guess and check, k and k, they both have to be plus signs, and this will be 2 and 6 exactly. And there are our 4 factors. Okay? I want to jump down to the very last one. We're going to skip that middle one. Yeah. Yes. Yeah. Yep. Yes. And you probably would see that, but I was just going to skip over it and get to the end. good call. Okay, on this last one, do we see how this 4x squared plus 5x and this 4x squared plus 5x kind of repeats itself? Okay, so I'm going to think of this as like y. So I'm going to think of this problem as y squared minus 5y minus 6. Is that factorable? It is, right? Typical trinomial. I'm going to cheat and just tell you it's y minus 6 and y plus 1. Okay? But I put that y in there. That y was not originally there. I kind of used that to replace this common expression. Y was the equivalent of 4x squared plus 5x, yes? So I'm going to now replace that. 4x squared plus 5x minus 6 and 4x squared plus 5x plus 1. And then each of those is going to get factored further. So there will be 4 factors at the end, 2 for this trinomial and 2 for that trinomial, which we're not going to have time to do, but I just wanted to have you see that structure. Okay, so your homework is there. It's still coming off the same worksheet. So the same worksheet you've been working off of in those numbers.